Nice to see just how many people have actually stayed around. We do our own training days, and getting people there at first thing in the morning and keeping them till lunchtime is one thing, but actually keeping people till late in the afternoon is a really good effort on all of your part in actually staying here and listening to the information we have. Thermal comfort or thermal discomfort, depending on where you sit, and just standing here looking around as the day's gone on, the thermal dynamics in this room will have changed. There are people wearing jackets and coats, there are people wearing shirt sleeves and blouses. Thermal comfort is something very, very personal to us as individuals. And meeting standards to achieve thermal comfort are really, really difficult where you have lots of people in space. A little bit of an overview about us. Hemlo, we're an M&E heating, ventilation, air conditioning contractor, covering really large commercial office. We have a varied portfolio that ranges from schools through to warehousing, but large commercial office, particularly large multi-tenanted businesses, are really our core aim. My role in the business, and really the reason I'm standing here talking today, is that I'm the company's CPD approved trainer, and we provide industry training to try and make maintenance make sense. And we cover things such as understanding your building and how they operate, meeting standards and achieving compliance, and modifications, alterations and their effects. And if we go back to a conversation, I think it was Joe that kicked us off earlier on, achieving thermal stability here, Cat A fit, is much easier than achieving thermal stability here. In the Cat B fit, now the tenants have actually put their furniture in and they've moved in and people have changed the space. Achieving that level of thermal comfort isn't just about the people. It is about the space and how we fitted it out and put our services and equipment in there as well. But we have to start with the individuals, the people that we're actually putting in that space, because we are all different. We all have our own likes and dislikes. We all have our own requirements when we come to work and the services and the aims and goals that we need to achieve before the end of the day. And dependent on the pressures that are put on you, you can spend some days in the office and feel really comfortable all day, a bit more pressure put on you and your thermal dynamics change and you can feel really uncomfortable. From a tenant's point of view, tenants simply believe that air conditioning is for their comfort, which it is. But what they believe that is purely that it's about being hot and cold and keeping the temperature stable. And we've already heard from people talking about air quality and other indoor standards that need to reach. One of our primary functions as a human being is that we breathe in the atmosphere we walk around in, deplete it within our body and breathe it out in a much worse state. There are some simple figures, and we did mention CO2. It's a really easy thing to monitor. Air conditioning systems have to look at keeping that basic air quality level to the right requirements for air quality as well as thermal comfort. And if you see there, we exhale about 0.4% of CO2, inhale about 0.4% CO2, we exhale about 4% of CO2, so a massive increase in CO2 levels. And while it's not actually linked to thermal comfort, it is actually linked to the way we can perceive thermal comfort. Stale, warm air in an office space can actually just make you feel a little bit uncomfortable and think that your thermal comfort's changed. But as we go through the presentation, hopefully we'll look at different factors that actually impact on us feeling thermally satisfied. There are really 6 factors to consider for achieving thermal comfort. The air temperature. Stands to reason. If the air temperature in the space isn't right, we'll feel too hot or we'll feel too cold. But it's the actual air surrounding the body in the space that we are working in. And where you put people in offices or large conference rooms and meeting rooms, the air temperature can change from one side to the other. It can change within a few feet. But where we're looking at controlling that air temperature, we always try and look mid-space or mid the actual area we're working in. We can't control temperatures to specific little zones. And as we go through some of the slides later on, we'll actually look at the impact that that has on individual people where they are sitting in the air movement. And that's the next thing we need to consider, not only air temperature, but the velocity of that air. Actually having air moving around in a space while people are sitting in it simply allows that air to move across our bodies. The speed the air moving across people is crucial to achieving good thermal comfort. If it's blowing too fast or too slow, we can feel too cold or too warm. Simple, small air movements are all too often perceived as drafts, because effectively we are sitting in it and we can feel it on our skin. As a maintenance contractor, we respond to emergency call-outs 24 hours a day, 7 days a week, as all good contractors will. About 70% of the calls we actually respond to during the working day are what would be classed loosely as a nuisance call. Flashing lights, noise, funny smells. They're not real emergencies. Too hots, too colds. People feeling thermally discomfort while they're sitting at work. And of those 70%, around about 80% of that 70 are purely people too hot, too cold. And we have a general rule of thumb that if you put 50 people in a room, 30 will be fine. They will very rarely moan about it at all. 10 will be too hot, 10 will be too cold. Because we are sensitive to that air movement. We always hear when they talk about the weather forecast, it's going to be 3 degrees today, but with the wind chill factor it'll feel like it's -5. Our bodies have a natural method of cooling down. We perspirate and sweat and our skin pores open up and it allows moisture onto the surface of your skin, and then if somebody wafts cold air across it, the evaporative process cools us down. We all sit on the beach or in the hotel swimming pools, 40 degrees, red hot, you sit there and you go, oh, I'm really hot, jump in the swimming pool, cool down, stand outside, and as the air blows across your skin you can actually feel a bit, ooh, just as you get out of the water. And it's that natural thermal cooling. So we do need to take account of air velocity. Humidity has to be a thought process in fully air-conditioned buildings. Relative humidity is what the engineers talk about, and it's the difference about the amount of water that the air vapour holds to what it actually can hold. We talk about relative humidity, 40 to 70% has no real major impact on thermal comfort, but if we are fully air conditioning a space to put tenants in, we need to consider it because the cooling process is a dehumidifier and can dry the air very quickly. Radiant temperature. If we're looking at thermal comfort in offices, we have to consider radiant temperature. Heat emitted from warm objects. What warm objects were there in there? Wherever there's a warm object, radiant heat is delivered. Radiant temperature has a greater influence on the way our bodies actually gain heat from the environment than air temperature. Examples of radiant heat sources include the sun. We all know if you sit in your garden, the sun shines, you're red hot, you go and sit in the shade, out of the sunlight you feel cooler. Sitting in your car with your air conditioning on at 20 degrees, if you've got your arm on the windowsill, it's only 20 degrees in the outlet, but your arm can still feel warm when you're getting that radiated heat. Likewise in offices, we sit people in front of large glass windows with nice views on the south side of a building. The people sitting nearer the glass will feel warmer than people sitting further away. But we also have to consider things like radiators, where we have perimeter heating systems. Sitting desks right on top of perimeter heating systems will mean the people sitting nearer will have a greater impact on their thermal comfort. So you have to start considering actually the layout and design of the space to put people in from Cat A to Cat B. And more consideration has to be given at all of these points, because achieving thermal comfort is all about meeting the main criteria, but also looking at some of the personal factors that we then bring with us. Clothing. As we said, we look around the room, there are people sitting with jackets on, there are people sitting without. Some people feel hot, some people feel cool. If we had a show of hands, there's probably 10 or 12 people that would go, oh, it's really warm in here. There'll be a few that say, oh, it's all right, it's not too bad. The clothing we wear has an impact on our thermal comfort. The insulating effect. We need to consider that clothing can be a cause of thermal discomfort or a control for it. We used to look after a record company years ago that had a simple email that used to go out in their office. It's warm today, please feel free to wear your bikinis. It's cold today, please feel free to put a cardigan on. And their facilities management team used to send out the email every day depending on how she perceived the actual temperature in the space. But not everybody can do that. If you feel cool, can you actually just put a jacket on? Did you bring a jacket or a cardigan with you to work? Is it available? Guys, if you're too hot, can you take a jacket off? Most people can, but there are some positions that where company uniform and company dress code can actually impact on how people feel. And it also needs to be considered when we're looking at achieving people's thermal comfort. You have a corporate approach, you have a nice reception area for people to come into, you make your reception staff, guys and girls, whoever it is, jacket and tie or blouse and skirt. If you're sat with that reception door forever opening and closing, letting in drafts and cooler air or warmer air through the summer, the uniform you're wearing can have an impact on your individual thermal comfort. Work rate and metabolic heat. People carry out physical tasks in offices. Some people sit at a desk all day and do very few physical tasks. Those that are active will generally feel warmer than those that are inactive, generally feel cooler. The impact of metabolic heat needs to be considered. The way our individual bodies actually deal and produce heat ourselves. Person's physical characteristics should always be considered. Size, weight, age, fitness, gender can all have an impact on how we feel today, tomorrow, 1 hour's time, 5 hours' time. It can change through the day as individuals. Even if the air temperature, humidity and velocity are all constant. Our personal development and our personal movement through the day can change how we feel. There are more calls just after lunch for people saying it's too hot or it's too stuffy in the office than there are at 9 o'clock in the morning. As people first come to work, you've been busy, you've been rushing to get to work, people tend to take their coats off, sit behind the desk and go, cool, it's a bit chilly in here, because your own activity getting to it means you are quite warm. And the call-out dynamic changes through the day. If we have to consider all the bits and pieces, we can't achieve thermal comfort for every individual unless you are going to put people in a little office, shut the door on them, hermetically seal it, and then force air onto them and force temperature control. But we can't do that. So we have workstations and we have work areas, open plan, meeting rooms, breakouts. Earlier somebody alluded to it, that you could possibly look to split spaces to do different temperatures and different things to achieve thermal comfort for the majority. But we produce heat at a rate proportional to our activity. Roughly, a typical office tenant will emit about 120 watts of energy whilst simply working at their desk. People operate equipment which produces heat. Most laptops, computers, fax machines, photocopiers all produce heat. They also produce a lot of other things, and we've spoken about air quality and VOCs, depending on the equipment that's going in, but they also produce radiant heat that we need to consider for people sitting close to them. We operate lighting, which produces massive amounts of heat. We need lighting to meet the minimum lighting levels, and lighting produces a lot of heat that people sit in and adapt to. So you would think if everything we do, everything we operate, and everything that we need to see what we're doing with produces heat, it's a little bit unusual that there is no legal high limit to a temperature within an office space. It gets us hot. There are some exceptions to that. There are some parameters around schools and educational establishments that say you shouldn't have above certain temperatures while the classrooms are occupied. But in general, for general office, there is no high limit. There is the lower limit that people get very excited about if it's too cold. Health and safety regulations require an office to be above 16 degrees C in the first hour of occupation. But again, where we're talking landlord, tenant, leased space, that is the agreed licensed hours that is written into the specification for the tenant's actual occupancy. We get call-outs at 7 o'clock in the morning for buildings. The managing director cycled to work, he's hot, he's got in early, cleared all his emails, and at 7:30 he's freezing cold in his office. Occupancy isn't till 9 o'clock. So it doesn't have to be above 16 till 10 o'clock, 1 hour into occupancy. And that again can be a bit of a problem. We can't achieve satisfaction for everybody. And there is guidance in place that says that the generally accepted design temperature for an office today should be 21 to 23 degrees C in the winter and 22 to 24 degrees C in the summer. But is there a possibility when we're looking at actual thermal comfort and well standards and actual health in buildings that across a large floor you could have additional temperatures and additional spaces, some at 20, some at 21, some at 22, some at 23, and move people around? But us as individuals might like it at 20 when we start, but the minute the boss phones up and says, you've got a deadline, I want this by 5 o'clock, please, you're under pressure and suddenly you want to move to a 20 degree area, and we simply can't have the transition of staff moving across space as we see fit. So we try to achieve the guidelines wherever possible. We looked at getting air into the space. If we can't actually get air in, we're going to struggle to control the temperature in the space and the air quality. Part F ventilation says that we should provide 10 litres per person per second of fresh air. So we have to throw air in to the building and we have to extract some of that stale warm air out. And if we don't actually achieve that very well, it isn't fully air conditioned. Likewise, if we simply install something into a space that heats or cools, it's not air conditioning, it's comfort, cool or space heating. To be fully air conditioned, we need to have control of the fresh air. We need to filter the fresh air, heat or cool it and temper it to actually get it into the space we need it to do its job. Dependent on the system will depend on the volume of air and how much we need to get in there. At the moment, all we have is an air handling unit somewhere in a building. We need to distribute that around the space, and what we tend to have is large ductwork systems that run up risers across ceiling plenums to deliver the air to the space we need, linked with some extract ductwork to pull the stale warm air out of the building. These linked to terminal units, 20 minutes is very quick. We're only going to look very quickly at a fan coil unit. This particular one is a heating and cooling 4-pipe fan coil. Air from the air handling unit is delivered to the back. The rest of the air is delivered from within the space. The warm air rises, permeates through the ceiling grid or out through the extract air ducts into the ceiling space and is drawn back into the unit, heated or cooled by the local controls or the BMS to actually control the space we're in. And there is a little bit of methodology that says if you can put a wall controller on the wall for a tenant that actually allows them to walk and turn it up and down as they see fit, they feel much more in control of their environment rather than having it run by a BMS system in a plant room and they have to log a call and wait for an engineer to make a change. The fan coil sits in the ceiling void. We're talking now, we're going from Cat A where we've achieved stable temperatures because the landlord system provides everything very quickly and very easily, and there are no dynamics that change. But when we put people in that space, we have to alter it very quickly. The fan coil unit sits in the roof, in the ceiling plenum above the tiles, connected to all the services to get air into the space. And the grills are the bit that sit in the ceiling. We've got some nice linear grills in here above my head. There's a few other little grills around the sides, I believe. certainly at the back, that are also allowing air in and out of the space. They are commissioned, as much as the fan coils, to make sure we achieve the air temperature and air velocity and movement the system needs. The grills can be diffusers, swirls, or offset grills, as these linear grills can have, so you can actually have two different airflows. And dependent on how they're in the ceiling is how they work. The next thing we do, obviously, we put furniture in the space because the tenants need to sit at desks and have equipment around them to work. And if we put furniture in an airflow, it has a disruptive effect to it. And you quite often hear people sitting at their desks, they can feel the air blowing on the back of their neck. Because the filing cabinets close by have been put right in where the air drops into the space and diverts it across. Quite often, if you have really high cabinets, bookcases, archive files, it diverts it to such a high level that it just confuses the space completely. And the mix of air really doesn't work at all. Putting people in the space adds that extra dynamic. This chap's nice and smiley, sat behind his desk working away all day long. However, as you can see, the two converging cold air flows are directly above his head. He isn't going to be happy for long. He'll have a cold head, cold hand, he's going to start moaning pretty quickly. So we either move him out of the space, or what tends to happen is the grills above his head are turned off, or the fan coils reduced in speed to accommodate him. We need to get the warm air out of the space. Most ceilings allow for that thermal evaluation to allow out, so the warm air ends up back in the ceiling void and becomes a return air duct. If we change the ceiling grid, or we change the light fittings or the tiles, and we trap that stale warm air in the space, it obviously has a knock-on effect to thermal comfort. If we change an entire ceiling grid to a full flat ceiling, it obviously impacts then on access to the services in, and we need to make sure that we put sufficient access hatches to allow for maintenance of all services. I'm going to wrap through these last two really quickly. If we had to divide a space, we talked very quickly about dividing a space, we need to understand how we're going to control it. Simply putting a partition wall into a space doesn't give total control of a system. Which side's going to have control and who's going to be in charge? And what are we actually making that space into? If we make that space into a comms room or a machine room, its knock-on effect to thermal comfort are completely different than if we put people in there. Quite often, to achieve tenants' requirements, what we're going to have to put in is additional systems that allow the tenant to then achieve their thermal comfort. And where landlord systems and tenant systems start to clash is where thermal comfort starts to become a real problem. Particularly where tenants are allowed to expand landlord systems by putting in additional fan coils and additional services onto their landlord's kit. If you want to know more, we do our own training events. There's some more information. I think I may have just overrun slightly. Thank you very much for listening.
Just stay there. I think what we'll do in the interest of time is we'll take questions now specifically on that presentation and rather do a panel discussion. But we're only going to have time for one question, and that question needs to be brief. So if it's going to be, I'm sorry, I said I was going to be unpopular today, so here you go. So can I just see a show of hands for a question? I've got one. Is there a competing offer? Someone at the back, you've spoken, so you win.
Very briefly, Glenn Blake Thomas. Very briefly, how does the fan coil system stack up with the well standard? Because it's blowing air down through the pollutant into the space. What's your view on that?
The fan coil and the services in the ceiling deliver known quantities at known parameters, and it should meet with the well standard, provided we don't start to affect it and alter it too much. Achieving it at Cat A isn't too much of a problem, as we've already said. Where we're looking at fitting out Cat A buildings, landlord's original fit, it will tick all the boxes. It struggles where we put occupancy and people in and make things alter differently. But this is a problem for system designers to look at in that initial concept, and where Overys were talking at the beginning about Cat A and Cat B fit. There are lots of people and lots of stakeholders in that initial process. Landlords are shying away from it at the moment, and tenants aren't really driving the issue. Where we have to look is that initial design concept is very early in the process, and if fan coils aren't the answer for the well standard in a particular building with a particular reason, let's look at something else and put it in there.
Right, okay, thank you very much. That's the question. Okay, thank you,
Thank you.
Thank you, Dave.